we passed the point of no return in this sector. And at this point, we'll say it's just a matter of time before these glaciers completely disappear to sea. We are seeing in this sector retreat rates that we don't see anywhere else on Earth. They're retreating at rates of about 1 kilometer per year. That may not seem much to people who are not familiar with these glaciers, but most of them don't change on those scales. There's probably nothing that can be done to stop this. It can be slowed down. For instance, if the ocean waters that contribute to the retreat of these glaciers don't provide as much heat to the glaciers, it might slow down, but it's kind of difficult at this point to see any physical process that would stop it. We don't have the tools right now to make realistic projection on what's going to happen there over the next 2 centuries. What we can say is that based on the last 20, 40 years of observation is that this system is evolving very fast and is progressing exactly as you would expect if it was about to collapse to sea. In terms of our future, well, that means we should definitely keep a close eye on that sector. It's certainly a wake-up call to improve our modeling capabilities so that we can project what's going to happen in this area with a little bit less uncertainty. We are on this path right now. There's a lot of efforts being spent in looking at this area in more detail and gathering critical data. We are heading towards a particular sector of West Antarctica draining into the Amundsen Sea. This sector is drained by 6 glaciers. The biggest ones are Pine Island Glacier and Thwaites Glacier. The speed of the glaciers measured by satellite is shown in color code. Red is fast, blue is slower, and green is the slowest. The glaciers flow into the sea and form floating extensions called ice shelves. Now in red are the areas where the flow speed is increasing almost every year. The darker the red, the more the glacier has been speeding up. You see that all the glaciers are speeding up. Now we focus our attention on the Smith Glacier, which is a smaller glacier, but which has experienced some of the most dramatic changes. The grounding line of Smith Glacier in 1996 is at the transition boundary between the blue color, the ice shelf, and the white color, ice resting on the continent. Now we transition to 2011. The grounding line is 35 kilometers farther back, a retreat of nearly 2 kilometers per year. If we could peel off the ice from the continent and see the bed, this is what it would look like. The arrows indicate the flow direction of ice. Their color indicates the speed. Blue is slow, red is fast. We see that the glaciers flow on top of major subglacial valleys colored in brown. The darker the brown color, the deeper the valleys. As the glaciers retreat, they will follow these deep valleys. There is no mountain or big hill along the way that could act as a barrier to hold these glaciers back. The glaciers speed up. The grounding line retreat, the deep valleys that are sloping inland, all reinforce each other to make the retreat of ice in this part of Antarctica unstoppable. And we think that this is what is happening right now.